So the next section is going to talk about reverse engineering. So there's basically two main thrusts of the course left. The first is going to look at reverse engineering, which helps us understand how embedded systems work. And then we're going to look at a few attacks on embedded systems. So we're going to take you through reverse engineering, which allows us to do software attacks. And then the final part of the course will look at hardware attacks. So what is reverse engineering? Well, reverse engineering is basically the opposite of forward engineering, right? So in forward engineering, we have a problem and we design a solution to fit that problem. Normally we have understanding requirements we have to meet. We have possibly, hopefully a well-documented design. Hopefully we're using well-documented features like we have app notes, we have data sheets. We can understand how each part works and perfectly select it. Well, reverse engineering is sort of the opposite problem, right? We're going from a final product and we're actually trying to get out of that some form of design documentation. The amount of effort, what we need can vary. So we might just need some very minor details out of this thing, or we might need really complex, data. We might be people use reverse engineering to clone products fully. So there's a pretty wide range of effort that can be put into it. So the two examples here, right? One of them is like if you have a circuit of some sort, right? You can get schematics, you can get a PCB and PCB layout from it, so you could recreate it fully. On the right side is just an example of software reverse engineering. So with software, we don't have a physical product. We have what we would call binary. So this is not like the compiler you're used to looking at where you get nice C code and comments. You basically may get nothing. If you're lucky, in some cases you get a bit of information about function names or something, but most of the time you won't even have that. It's going to be a very common part of security research, so this is why we're going to include it. This course is not a full introduction to software reverse engineering. Basically, the objective is to get you a little bit started, understand where you would go for more information. But seeing it hands-on, I think, will be very useful. So the first lab in the course will just be a very short introduction to a popular free software reverse engineering tool called Ghidra. And we're also going to look in particular at ARM Cortex-M language. So ARM Cortex-M is used in quite a few of these small microcontrollers, so you'll find it in a lot of like IoT devices, a little bit of automotive now. It's not as popular there. But we just have to pick one particular language to go with. The concepts are highly applicable to anything else that you find. A really good resource, so if you really want to dig into this, which you may have to for depending what you select as a project, you might want to dig into this a little further. So Azaria Labs has some really nice tutorials and workthroughs on this. So she's put a ton of effort into this. There's also trainings as well. But for what you're doing, you'll probably be able to go through some of these experimentations. And there's even an online assembler to help you with that and some lab setup stuff. So this is a really, really good resource if you're interested in learning more, in particular about ARM assembly. What we're going to end up doing is using the Ghidra tool to help us sort of highlight some of this. So we won't actually dig into as much of the specifics when we go through this. And what we're going to cover in sort of some of the following lectures is taking a look at C and how that translates to assembly. So some of this you would have learned already in computer architecture and some other courses, but I want to rehash a little bit about how you can explore this. The important part is seeing how you can actually explore this yourself. And we're going to look at a few features of that, like functions calls that are going to come up frequently. And finally, later on, we're just going to sort of look at a few binaries to see how you could understand what they're doing. There's a lot more you can dig into this with, but this is just going to cover some of the introductory material.